Texan Global School. Trigonometry Summary. This video shows the critical points to understand trigonometry. It must be understood that a right triangle is one that contains a right angle or a 90-degree angle. Only in this type of triangles can we use the Pythagorean theorem, which indicates that the sum of the squares of the legs of a right triangle is equivalent to the square of its hypotenuse. Let's remember that the hypotenuse is the largest side, which is opposite to the right angle. It is also important to remember that the Cartesian plane is divided into 4 quadrants, which are arranged in a positive or counterclockwise. Quadrant 1 contains coordinates where the abscissa and ordinate are positive. In Quadrant 2, the abscissa is negative and the ordinate is positive. In Quadrant 3, both are negative. And in Quadrant 4, the abscissa is positive and the ordinate is negative. An analyzed and related concept is the angle in standard position, which is the one in which its vertex is at the origin of the Cartesian plane, and its initial side coincides with the positive side of the abscissa axis or x-axis. From this angle in the plane, a point with coordinates x, y is generated. And from this point, a right triangle is formed, from which we can calculate the trigonometric functions and their ratios. There are 6 trigonometric functions, which are sine, cosine, tangent, cotangent, secant, and cosecant. According to the quadrant in which the triangle is generated, the signs of the trigonometric ratios are determined as shown in the table. The diagram shows the unit circle with specific points, which generate exact values. For example, the square root point of 3, 1 generates an angle of 30 degrees. It is convenient to take this into account since it makes it easier to simplify expressions with trigonometric elements. From this circle, we can obtain the table with all the exact values of the trigonometric functions. Let's remember that these tools are used for right triangles only. And for oblique triangles, that is acute or obtuse, we can use sine law or cosine law. The law of sines indicates that in every triangle, the sides are proportional to the sines of the opposite angles. The law of cosines indicates that in every triangle, the square of one side is equal to the sum of the squares of the other two, minus the double product of the same sides times the cosine of the angle they form. Let's remember the notation of triangles to solve this type of problem. The sides of triangles are represented by lowercase letters and the angles by uppercase letters. Likewise, when talking about solving a triangle, this involves obtaining all the missing sides or angles. To convert between degrees and radians, remember that an angle of 1 degree can be divided into 60 equal parts called minutes, and each minute can be divided into 60 equal parts called seconds. It is also essential to understand that 180 degrees are equivalent to pi radians. So it is not necessary to learn formulas. By simply using rules of 3, you can make conversions between degrees and radians. Sometimes we may require the use of the circular sector, which is the portion of a circle delimited by 2 radii and a portion of the circumference called an arc. Using the formulas shown on the board and drawing a straight line between points A and B, we can also obtain a triangle and use one of the previous tools. Let's remember that an identity is an equality that is true for every value of the variable. Identities are not solved like equations. Identities are checked or verified. So to verify a trigonometric identity, we must select some member of the identity. Work with that member without altering the other. Transform everything based on sines and cosines. Use identities to simplify or expand that member, and thus verify that it is identical to the second member. The 8 fundamental identities are shown, as well as others that will be used in different problems. Let us remember that a function is the set of ordered pairs, in which there are no different pairs with the same first element. The single argument trigonometric functions are shown on the board, and they can be graphed using exact values. In its behavior, we can see that the sine is the same as the cosine, but out of phase by 90 degrees, or pi radians. Both have an amplitude of 1, since it is the numerical coefficient of the function. The tangent has asymptotes, so its amplitude is infinite. A cycle of each function is shown graphed in the diagram. They are also called periodic functions, since we can continue graphing periods t forward or backward constantly. If the argument begins to be altered in those same functions, then they are called a composite argument with the elements shown. Finally, to solve a trigonometric equation, we will use algebraic processes for solving equations and various trigonometric tools. We can solve linear or quadratic equations as appropriate, and later analyze the functions to obtain the angles. As seen in the example, all the previous tools are used depending on the case.
Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com